Hello dear students. Today we are going to discuss about the effect of time interval, that means time dilation. Effect of time dilations. The time interval between two events are also influenced by the relative motion of the frames. Consider two inertial frames S and S dash. Let S be at rest and S dash moving with a velocity v in direction of x-axis. Initially, let the two frames coincide at t equal to 0 condition. This type of frames we can discuss in the previous classes. Let two events occur at a point x dash in the frame s dash at the time t1 dash and t2 dash as noted on the clock carried by the observer in that frame. The time interval between the two events measured in the frame s dash equal to t2 dash minus t1 dash. The two events are observed from the stationary frame S and this occurs at time t1 and t2 as noted on the clock in this frame. Hence, the time interval between the events measured in the frame S equal to t2 minus t1. Here, in the case of S dash frame, the time interval is t2 dash minus t1 dash, but in the S frame, time interval S equal to t2 minus t1. As you know that a Lorentz transform equation t dash equal to t minus vx divided by c square root of 1 minus v square divided by c square. These equations we have already studied. S dash is moving with the velocity with respect to s. It means that s is moving with the velocity with respect to s dash. So we have to use the inverse Lorentz transformation. But in the case of inverse Lorentz transformations, above equation v is changed to minus v and t dash are interchanged. Here it is t equal to here t dash plus vx minus c square root of 1 minus v square divided by c square. Applying the above Lorentz inverse equation to the two events in the respective frame S and S dash, we get t1 equal to t1 dash plus vx minus vx dash divided by c square root of 1 minus v square divided by c square, one equation. Next equation is t2 equal to t2 dash plus vx dash divided by c square root of 1 minus v square divided by c square. t2 minus t1 equal to t2 dash minus t1 dash divided by 1 minus v square divided by c square. This is a simple substitution, but we have to read this in your notebook. t2 minus t1 equal to delta t. That means time interval recorded in the stationary frame S. Then again t2 dash minus t1 dash equal to delta t0 is the time interval noted in the moving frame S dash and it is called proper time interval. t2 dash minus t1 dash equal to delta t0, it is called proper time interval. Thus, the proper time interval is the time interval measured by the single clock between events that occurs at the same place as the clock. The event take place is S dash. The clock is moving in S dash with respect to S. That means delta t equal to delta t0 divided by root of 1 minus v square divided by c square. Since 1 divided by root of 1 minus v square divided by c square is always greater than 1, then delta t is greater than delta t0 always. The time interval of events observed by the clock in the rest frame appears longer as compared to the time interval recorded by the clock in the frame S dash. Hence, the clock runs faster in the frame S. At the same time, the moving clock runs slow and the time interval appeared to be expanded or dilated due to this effect. The clock in the moving spaceships will appear to go slower than the clocks on the surface of Earth. This is called time dilation. We can connect this paragraph to the equations. Then next we are verifying the experimental verification of time dilation. Time dilations have been verified in the case of elementary particles like mesons and pi plus mesons are produced in the atmosphere at Earth due to the interaction of cosmic rays with the atmospheric gases. Here, pi plus mesons decays to mesons and which is very short. Then we can see here it is the mu plus muon is the 2.2 into 10 raised to minus 6 second in the frame in which they are rest. Then hence the distance it can travel in that lifetime is 0.998 c. Then we can see that here is the distance 0.653 kilometer. Since muons are produced in the atmosphere at the height of 10 km above the surface of the earth, no muons are expected to be present on the surface of the earth. But experimentally, an appreciable number of muons are detected on the surface of earth. After the calculations for the in the side of observers, we can use the delta t equal to, we can substitute this into the these values into the equation. That means delta t0 divided by 1 root of 1 minus v square d square. Then delta t, we can see it is 34.80. Also we can substitute in the above equations. We can see it is 10.4 meter. Without the time dilation, distance that can be covered, the muon is 0.66 kilometer. We can see it is the 0.66 kilometer. But when there is a time dilation, the distance increases to 10.4 kilometer. After the calculation, we will see 10.4 is the after the calculation. But here it is the time 0.653 kilometer. Here it is the 10.4. I think it is 4 kilometer. You can change it. This explains the presence of musons near the surface of the earth, thus verify time dilations. This is the experimental verification of time dilation. Okay, thank you for your attention.